one force like this, and there are two positions, right? So you will calculate the position vector, then you will convert it into the unit vector, then use this unit vector with this force FAB, right? And make this like X, Y, Z for this force, FAB. So you will do this for one force and you will do the same thing with the other force, right? You have two forces like this. So just think of same question, but you have two forces. And then you need to find the resultant, which means you need to add them as well. You know, once you know this for FAB, and once you know what is FAC in terms of X Cartesian form, you need to join them. You need to add them together, you know, like to get the resultant. So can you try to solve this thing at your end? Okay, so I'll give you some time now. Maybe you solve it and then we'll match. We'll see then if you're getting the right values or not. So let's take 10 minutes to solve this question. You have, let me erase this thing so you have the better understanding. One thing you can do, and I can give you this tip, it's your choice. You take this as an origin or you take this as an origin. You know that once you take the origin here, things will get simplified, right? Why? Because whatever you get here, it will be taken right away as a unit vector because the other things are zero. So your choice, your call, whatever you want to do, you can use it, no problem, and then we can look into that. So let's take 10 minutes and then you try to find this. First, build the position vector. So from A to B, what is A to B position vector? What is this position vector? RA to C. Then calculate the unit vector, use the unit vector together with the forces, get two forces in Cartesian form and then add them together, like, resultant. Yes, students, once you're done this thing. Done? So, what about you, sir? Done? Okay, let's see. What is the RAB? And we'll start with first the coordinates. So, what coordinates you picked? This is 0, 0, 0, or you use the 0 other one? 0, 0, 0. This is 0, 0. Okay. So, what would be the coordinate here for B? 0, 4, 4. 0, 4, 4. So, what you have this x, this is x, 4, right? X is 4. This is x axis, right?
I took it for y.
So this is 4, 0, 0, and then it's minus 4 because it's down, right? So 4, 0, minus 4, right? Remember, because origin is above. So when you come to the minus z side, it would be minus 4. This is minus 4, right? And what about the other coordinate for C? What do you think? What is it for C? Same coordinate. This is first 4. Then you have this 2. Y is 2. And then this one is minus 4. Right? So I know the position vector because the other one is 0. This is simple. Now you just simply write it like 4i plus 0j minus 4k. Right? This is RAB. And you can write RAC as 4i plus 2j minus 4k. Now, what's their magnitude? What's the magnitude? 4 square plus 0 square plus 4 square.
A is 5.65.
5.65.
And AC is 6.
AC is 6. Okay. This is 16, 16, 32, 32 plus 4, 36. And then you calculate the unit vector. Unit vector for AB is 4 over 5.65i plus 0 over 5.6. I'm writing 0 so you know this is 0. But I keep writing it so that you can see this. And here the unit vector for RAC is equal to 4 over 6i plus 2 over 6j minus 4 over 6k. Right? So these are the unit vectors. Now I know for AB the magnitude is 100, right? So I want to make the force vector AB. So I just simply multiply 100 with these ones, right? So when you multiply 100, this is like 400 divided by 5.65, right? So 100 divided by multiplied by this one. What's the number, guys?
33. No, I mean 70.79.
So this is 70.79. When you divide 400 by 5.61, right?
Yes.
This is I. This one is 0, right? 0j. And k is equal to again 400. So the same thing but with minus, right? Yeah, okay. So I'll write this one minus 70.79k. This is the force vector AB. And what is the other one? You multiply 120 with these numbers.
The first one, 80.
FAC is 80I.
The second one is 40, and last one is minus 80.
40j minus 80k. And then the question is asking you determine the resultant force, which means that you will, whatever is happening is an x, you will add them, or whatever is, if there is subtraction, you will subtract them, right? So 80 and 70 resultant would be equal to 80 times plus 70, it's 150. 150.79 I. 0 will add with 40 and it will remain 40 J, right? And this minus 150.79, that will become K. So you got the resultant force by adding these two, right? Adding or subtracting depends on the signature. You just take the net effect, you know that. Then the question is saying, express the result as Cartesian form. So this is already Cartesian form, right? And you can also calculate the magnitude for this one. If they are asking, yeah, because sometimes they ask the magnitude as separately, and sometimes they also say, figure out the alpha beta gamma for this one, right? Although here in the question, I only see this one. So if they are only saying Cartesian vector means only till here, right? But sometimes they go one step more ahead. They say that you also mention the magnitude and also mention the alpha beta gamma, the angles, direction angles.
So for alpha beta gamma, we use this 4 over 5.65.
First, you will calculate the magnitude.
Yeah.
And then, yes, 150 divided by the magnitude, this is cos alpha. This 40 divided by the magnitude, this is cos beta.
How will we find this for the resultants?
Yes.
Okay.
So if I show you the numbers, this was right. I was just writing 0 in it, right, for the J. This is right. And then when you add, this is right. We were getting 150.7, right, which is approximately 150, right? Make sense, students? Is it making sense to you? Okay. Now we go to the next part, which is now the dot product. So dot